Hello, my name is Vimarsh and I'll be covering the topic data governance for AI security officers. I belong to telecommunication industry where security and governance go hand in hand and is also a critical factor in any organization. Security helps in protecting our boundaries with necessary controls, and governance ensure all policies and procedures are followed properly and effectively. Uh, Recent years, we have also seen the growth in AI industry, innovation, implementation, and usage. I believe this is the right time to initiate effective governance in this industry. Uh, I'll say for years, security officers were related to safeguarding the boundaries of the organization, as in network, data, ports, and all these factors, and any endpoints in the network related, including our laptop, computers, and all. We built higher walls and stronger gates as a security officers. We secured the perimeter, but today our adversaries are not just trying to break into the fortress; they are trying to poison the kingdom as well. So what it means is basically now. Basically that the attack is more on the inside, which is on the data, right? They are poisoning our database and all. So I think for a security officer, the game has fundamentally changed. Our biggest vulnerability is no longer just an open port, it's corrupted database or stolen training data. That is why data governance is no longer a compliance task for the back office. It is now the most critical frontline control for AI security. So basically, in this session, I will focus on the three core principles of data governance that we must champion to secure AI, which is provenance, privacy, and monitoring. What is provenance? To start with, provenance is basically tracking, keep record of your data from the start. From you can give an example as farm to the table, from basically scratch till the end, from basically the design phase to coding to implementation, and then to the production, and then to the operations. Every phase the data moves. The ownership has to be very clear, right? Who owns the data and who has the rights to manipulate the data, and who can be the administrator of the data, right? So why I'm saying this is because let's say AI model has been trained on from an unknown source or untrusted data. So imagine the catastrophic risk associated with it. The data may be poisoned, and which basically teaching your AI a hidden backdoor. I'll give you another example is let's say malware detection system model. Basically, the data poisoning went to that level where specific type of ransomware is considered as safe. So as a security officer, we must enforce a strict chain of custody for data. This means championing centralized data catalog. So as a security officers, we have to start maintaining a centralized data catalog for every data set. Also, I think as a security officers, we have to think about cryptographic hashing to fingerprint your data upon arrival, so that in any in the hashing algorithm, basically if any modification happens to the database, there will be the hash code will not match, and hence if let's say you are monitoring your data over the life cycle, there will be chances that you will detect that change, and basically the data owner can take action accordingly. And I hope you understand that if you garbage in the data, it will come out as gospel. So this is a recipe for disaster. So second point I'll cover is the privacy. I'll say for too long we have seen data privacy as purely as a legal or ethical issue. We need to start treating it as a core security control. For every piece of personal information in your training data is a liability. It's a target for attackers who want to reverse engineer your model to uncover the sensitive data. Any data associated with any personal information needs to be treated as secure as possible. Without the authority of the personal, it should not be shared with any person or any organization. I'll just say that in the model, basically the techniques which are used are differential privacy. What does it do is it add a noise to mathematical noise to the data, so we can train incredibly accurate models while making it impossible to identify any single individual within the data set. Think of it as a digital witness protection program for your data points. Another powerful tool is synthetic data generation, which is also exact, you can say, the replica of the data, minus the personal information, which is like statistically identical based on the patterns, but not the people information in it. So I can say by aggressively anonymizing the data before it ever reaches out to data scientists, we shrink our attack surface. By doing this, we are actually reducing the threat, right? Reducing the impact of a potential breach. And we can say anonymity is a security control. And now the last thing is monitoring. Finally, monitoring. Basically, what monitoring do is they always monitor for the model drift, right? That means you have designed something, or you have made a model will not last forever. You have to keep changing according to the conditions or the surroundings or the logic or the behavior of the person, right? So once a brilliant AI was made, will decay slowly and will become a silent liability unless we keep monitoring it and develop a dashboard of vital signs. So what those vital signs can be, right? One of the example is concept drift. The underlying relation, this concept drift is basically the underlying relationship between the input and the output changes, right? So let's assume that that we have designed a fraud detection model trained based on some transaction patterns, which may fail when new fraud detection techniques emerge, right? So this is called concept drift. So the model which is relevant now may not be relevant in future. Same goes with data drift, right? Where the input data distribution changes. So now we are saying the input data itself change. But the relationship between input and output remains the same. The logic, the model logic, everything remains the same, but input data itself has changed. As an example, cybersecurity model trained on traffic from one network environment may struggle with when deployed in another network provider or network environment, right? So this is called data drift. Here the input of the data has changed. And then the label drift, which is also a very important one. It depends on the pattern. So the proportion of spam emails over the time may change, right? So this is called as one of the label drift. So why these drifts needs to be monitored, right? Because there are lot of false positive and false negative in threat detection system. Attackers may intentionally cause drift to bypass the security model, right? Which I mentioned, poisoning of the data, right? Outdated models may miss or evolving threats. New threats, zero-day attacks will also be missed if outdated. So what we have to do, basically, then it has to be a continuous monitoring and alerting, even the hashing one, right? Everything needs to be monitored and regularly trained. Basically, online learning and drift detection algorithm. So all these drifts which we have talked about, these needs to be detected as well, and any adversarial robustness needs to be detected as well. So in the end, I will say that championing these three things like provenance, privacy, monitoring, it will help AI remains as secure as possible and reliable over the time. And by mastering data governance, we do more than just protect our system. We build the trust that is essential for this technology to reach its full potential. We move from being guardians of the fortress to becoming the architects of a truly trustworthy AI future. I believe that's it from my side, and thank you very much.